Hey guys, and welcome back. So this is the preview for the sim that we did together, and I'm pretty happy with the result. I think we forgot to set up the mass, so the pieces are falling at a different speed compared to everything else. So we want to set up mass at least as something constant in this example would do. We don't have to compute the attribute in SOPs. And I think that's pretty much it. Maybe here there's a lot of pieces falling, but again, Kong is inside these guys, so that could be the reason for that. And we can also increase the constraint for the wood, and maybe the right way to do the wood is actually to treat it like the other wood structure that we did. But I will leave that to you guys. You can see how the planks are pushing the tiles underneath and shooting them outward. Now what I'm going to show now is a technique that I use to create explosions on RBDs. It's a very simple method that I use, and we can use it here to fake some impacts at the beginning and maybe help all these guys from falling down. So let me cancel this. I'm gonna save it as end, and I'm gonna save this explosion.v1. And what I did to preview this is basically imported the same RBD object like we always do, and then the point cache, and then a transform. So we all know how to do that. Okay, so the best method to create impact forces is using in RBD. There's multiple ways, but the best one I found is to use a technique with particles that works with particles, and the method is to create a volume with velocity field and use a pop advect field and advect the VDBs using that volume. This works great if you have actual explosion that you want, if you have a sim that you want to push the RBDs with, and I'm going to show how to weaken or delete the constraint where the impact is present. So let's start with creating a line. I'm gonna have to face the z-axis, and let's set the length to 4, and just need 2 points. And I'm gonna create a point at 0, 0. And I'm gonna use a point replicate to copy the points. I need something like this. Let's change it to a sphere and scale it down. And what I want to do is I want to create a vector that shoots outward from these guys. So I'm going to use a transform node and select this, push it, and scale it. And if I template this, I want to compute a vector between this and this point. And then we can easily use this transform to manipulate the vector. So let's put down a wrangle node. I will want to import position target, or just target. And we'll want to import from the input number 1 the attribute p, and it's at ptnum for the ID. And then we want to compute velocity, so v equal current p, or target minus v at p. Okay, if I view this, see now we have velocity vector. Let's put it in the normal. See now we have velocity, or a vector pointing that way, and I'm gonna let's increase it. Yeah, 10 is good. And I'm gonna now we have these points. We can simply scale like this, or push them back, and that will give us the orientation. And this is to represent some kind of spikes that we get from the explosion. Okay, cool. So now we have that. Gonna store this as v for the velocity, and I'm going to I'm going to use actually let's store this as n, and I'll explain in a second why. I'm going to use a copy 2 points. I'm going to copy that line that we just made to these points. And see, now we have a line pointing along the direction of the normals. That's why I put it facing the z-axis, because that's what the node this will align to. So now we have a vector pointing along each of the pointing along the normals, and we can introduce a scale attribute. So let's put a random, not this. P-scale, and I want it to be a single float. I want it to go from 1.5 to 1. So we have different random length on these guys. The length is not going to matter too much, because at this point it's not going to matter too much. Okay, so the next thing is I want to resample this. Okay, and I want to add more points, something like that. And if we take a look at, we don't have a velocity, we don't need that at the moment, I just need n. And I'm going to use a polyframe node. And with an explosion, the spikes represents the direction of the, an explosion, these spikes represents the direction of the velocity. So if we compute the tangent, which is a vector that travels along this curve, we can get the orientation that we need. Okay, so simply computing the tangent and storing it as n, and if we visualize that, you see we have a vector. Let me delete all the points so it's easier to see. Not here, but here. Delete points, but keep geometry. Delete geometry, but keep points. You see we have a vector. And that's going to be our velocity vector. Actually, let's put it as v. So that's our velocity vector. We need to inverse it. So v multiplied by -1. And then we're going to use a VDB from particles. And we're going to compute a density. Let's lower this. We want to convert this into a volume. And let's set this to 0.1. I'm going to lower the point scale and this as well. And let's lower this to 0.05. More, 0.02. And let's increase this to 0.5. Now we have something like that. And then we can sample the velocity. So V, I'm going to call this vel. So we have a density field and a velocity field. And if we create a grid, placed at the center, let's increase the number of points here. And I'm going to delete, I just need points. We use a volume trail to visualize the velocity field on this guy. So vel, you see we have a velocity field on the volume. Let's increase the number of points. That's too much. Cool, so that's pretty much it. And we're going to use this information to advect the RBD. Okay. Cool. So the next thing is I don't want this to be facing this way. So before we compute the tangent, I want to place this into the right location. So let me template this guy and find it. So transform. And scale. Okay. Then let's change this. Let's increase this because increase the resolution because we scaled it. And let's change this as well to 1. Maybe a bit bigger. Cool. Something like that. And we can increase the number of points, I think, to get more curves. So let's do that. Come on. Okay. And I'm gonna call this null out volume force. And it's don't need this. I'm gonna copy this guy. And let's go to the RBD system. And I'm gonna lower the threshold, the substeps, so it's faster to work with. And I'm gonna set the mass for these guys. So instead of density, I'm gonna give it a mass of 100. And here I'm gonna use a VDB advect by volume, pop advect by volume. And to be able to connect this, we need to use a multi-solver. So I'm gonna connect that and disconnect this. And then we connect the pop advect field node. I'm gonna paste the path for the volume force, and let's set this to a really high number just to see how it works. And I'm gonna disable the constraint network so we don't have anything holding it together, and let's see what happens. Cool. So it looks like it's working. It's doing something. And I'm gonna turn off treat as wind because we don't want it to. This adds some kind of drag feature that we don't want. We just want to push the RBD. So, yep, you can see we're getting some really nice explosions there. Cool. Okay, so the next thing I want to do is I want to you know what, let's go back. I want to finish one more thing. So let's turn back on the constraints now and hit play and see what happens. It works. We still got the motion and the constraints are breaking, but this is not always the case. And if that happens, if that showed up to be the case, you can see it's not pushing everything. What we can do, or what I recommend doing, especially if the constraints are much stronger, I would import the volume here, and I'm gonna scatter points, let's say 10,000, and then I'll just use a color here, and then I'm going to do an attribute transfer for that color, and then I'm going to delete those, all of them. I'm simply going to delete them. This way we don't hold the constraints we don't hold the force with the constraints, because if you have a glue constraint, this method, this advect field, this pop advect will never break the constraint, because we use either impact or other kind of attributes that requires the sim to be moving. So if it's at this state, it will never, the pop advect field will never be able to break the constraints. So using this method, we can delete them by hand. So here I'm deleting all the constraints. We can lower this to 0.5, 0.7, and this way the force is gonna interact a lot better with the geometry. Yeah, you can see that already. Okay, so the next thing is I want to show you guys how we can add multiple impacts. So we want one here and one here and one here, and maybe other ones on the building. And this is something I wanted to, I actually encourage you guys to try, because what we can do is we can destroy this building using this technique. So we can put an impact in there, we can put an impact here, an impact here, and even not have Kong at all. So we can just destroy it using this technique. And we'll continue setting this up in the next video. Thank you guys for watching, and see you in a bit.